Okay, so what we're going to do is we're going to do rational root theorem in order to learn how to graph these functions. So for me, when I see this negative out here, it concerns me sometimes. So when I do my factoring, I go ahead and pull this negative out. And that way I have 2x cubed minus 3x squared minus 11x plus 6. That makes it easier for me to look at it because now I'm not dealing with that negative. So let's take a look at this. So P's and Q's. My P's are plus or minus 1, 2, 3, and 6. And my Q's, I look at this first number here, are plus or minus 1 times 2. Okay, so then I go my P divided by Q. P divided by Q. Well, 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. 1 divided by 2 is 1/2. 2 divided by 2 is 1, but I already have that. 3 divided by 2 is 3/2. 6 divided by 2 is 3, but I already have 3. So these are my possible roots. If this thing is factorable, it has rational roots. This is going to be one of them, okay? So when I do these, I always start with plus 1. It's just easier for me to start with plus 1. So let's take a look at plus 1. Plus 1, I write my coefficients and constants. Now I've changed the sign, so let's go with 2, negative 3, negative 11, and 6. Draw my line, bring down my 2. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. That gives me negative 12. It gives me negative 12. Which gives me negative 6. So that won't work. I didn't get a 0. So let's try negative 1. Negative 1. Same coefficients, 2, negative 3, negative 11, and 6. Draw my line, bring down to 2. 1 times negative 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 1 times negative 5 is positive 5. Negative 11 plus 5 is negative 6. Negative 1 times negative 6 is positive 6. So this is 12. So this didn't work out. So let's try 2. 2, negative 3, negative 11, and 6. Draw my line, bring down to 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. That would be negative 9. That would be negative 18. And that would be negative 12. So that didn't work. So let's try negative 2. Like I said, some of these could be long. Let's see. 2, negative 3, negative 11, and 6. Draw my line. Drop my 2. Negative 2 times 2 is negative 4. Negative 3 plus negative 4 is negative 7. Negative 2 times 7 is positive 14. Negative 11 plus 14 is positive 3. Negative 2 times 3 is negative 6. I got one that worked. Zeros. So what I'm left with now, so far, let's see, is x. I have to change that sign, plus 2. And I'm left with these numbers here, 2x squared minus 7x plus 3. And then I have to remember what the math teacher taught me, how to factor these quadratics to the leading coefficient. I go 2 times 3 is 6. what two numbers will break down and multiply and get -6 and add and get +6 and add and get -7. Well, that's a -1 and a -6. So I bring this down, 2x squared. I bring this down, 3. And I break this up to its components, minus 1x minus 6x plus 3. Okay, so now I group 2x squared minus x minus 6x minus 3. Well, common here will be x, so this is x times 2x minus 1. Well, I can take a 3 out, so that's 3, 2x minus 1. Put the 2x minus 1 on the front, 2x minus 1 times x minus 3. And I bring this first one back down, x plus 2. Okay, now I have my three factors, so now I can graph it. Let's think what the end behavior is here. I have a negative 2x to the cube up here. This negative 2x to the cube is odd negative, so that's up, down. Here is my y-intercept, -6. So let's see what this thing's going to look like. Let's draw it. Let's draw my y-axis. Let's draw my x-axis. And then let's draw some points on here. So let's see what we have. We have a -6, that's down here. I have a -2, 1, 2, that's right here. I have a positive 1/2, so that's 1, and 1/2 is in the middle. And I have a positive 3, 1, 2, 3. I look at my end behavior. It is up and down. And then all I do is I get my pen and I connect the dots. So this goes down here, hits this point, goes up to here, hits that point, comes right back down, and that's how my graph looks. And that's kind of how you do the entire rational root theorem with the graph.